Hi, I'm Herb Gross, and welcome once again to Gateways to Mathematics, where today we'll be discussing Module 6. It'll be our third discussion in the heading of rational numbers, and the particular topic is called mixed numbers. As the name may imply, it's part whole number, part fraction. I've locked myself in to sort of tell a little story at the beginning of every discussion, whether the story is funny or not, but a very silly story came to mind just as I was getting ready to give this lecture. I was reminded of the story of one little boy who said to the other little boy, "What's your name?" And the boy said, "My name is 7 1/8." And the other little boy says, "Where'd you ever get a name like that?" He says, "I don't know, my father just pulled it out of a hat." Where do numbers like 7 1/8 come from? What causes a little kid the day after his 6th birthday to say, "I'm 6½ years old"? Do you ever notice that language, 6½, 2 3/4? You see the 2 is a whole number, the 3/4 is a fraction. These together are called mixed numbers, and this is what I'd like to discuss today. But the real gist of today's lesson is going to be to show you that in a manner of speaking, the worst is over. Well, maybe the worst is over. If you really understand the first 5 modules, with the exception of word problems, the next 3 lessons are going to be more of the same. If you don't understand the modules on common fractions, we're going to have a bit of a problem, because we're going to explain the rest of the ways of describing ratios in terms of how we describe common fractions. So without any further ado, let's go over to the board and start today's discussion. As I say, the topic is called mixed numbers. Let's suppose that I'm putting 2 books into a carton. I have cartons that hold 2 books each. And now I have 9 books. And the question that I ask is, at 2 books per carton, how many cartons are needed for 9 books? Now, I've picked small numbers here, so it's easy to count. In other words, these are the multiples of 2 again. See, every 2 books fill a carton, so I need 1, 2, 3, 4. See, 2, 4, 6, 8. 4 cartons will hold 8 books. Then the remaining book goes into the 5th carton. But in the language of fractions, you see, the problem looks like this. We have 9 books at 2 per carton. Remember how we say this? Division. See, the problem is how many books per carton? Books per carton, 9 books, 2 to a carton. So 9 divided by 2. And how do we write that as a common fraction? 9 over 2. By the way, the numerator, when it's bigger than the denominator, is given a funny name. People sometimes refer to that as an improper fraction. I don't happen to like that name. See, there's nothing improper about 9 halves. In other words, if you have 9 half dollars, that's the equivalent of $4.50. You see, just because you can trade in 2 halves for 1 doesn't make 9 halves improper, but people somehow don't like to have a bigger numerator than a denominator. But without further ado, let's just forget that for the time being. We have 9 over 2, and how do we turn that into a division problem? The easiest way to remember this is keep the 2 in place and pivot the 9 into the dividend. You then say what? 2 goes into 9 4 times. 2 times 4 is 8. 8 from 9 is 1. If this were the 3rd lesson, we would write this as 4 with a remainder of 1. But instead, we now write this as 4 and 1/2. And we read this actually as if it was 4 plus 1/2. In other words, how many cartons do you have? You have 4 full cartons and half of another carton. In other words, you have 4 full cartons and 1 of the 2 books that you need to fill the 5th carton. So you need 5 cartons, 4 of which are filled, 1 of which is half full. And the point that I wanted to make is that 4 with a remainder of 1 can sometimes be a little bit ambiguous. See, let me ask you a different problem, but it's similar, but it's different. Watch. I say at 3 books per carton, how many cartons are needed for 13 books? So 3 books go into each carton, so we're going to divide 13 by 3. In other words, instead of 9 divided by 2, this is going to be 13 divided by 3. That's 13 over 3. That swings the 13 down. 3 goes into 13 4 times. 4 times 3 is 12, with a remainder of 1. In other words, notice that the answer to problem number 2 in this form is also 4 with a remainder of 1. The same answer as we had in example 1. But now you see the 1 stands for what? How many would it take to fill this carton? It would have taken 3 books, so this is 4 and 1/3. You see, this is 4 plus 1 of the 3 that it takes to fill the carton. Now, Let's work the problem in reverse. Suppose somebody told me that I had 4.5 cartons. How would I figure out how many books that was at 2 books per carton? You see, basically, the way we do this is we say, look, if there are 2 books in a carton, if I have 4 cartons, I have 2 4 times. See, 2 4 times, that's 8. Plus 1 more in the 5th carton, that's 9. So 4.5 cartons would be 9 books. If it's 2 books to a carton, each book is a half a carton. See, 2 books per 1 carton is 1 carton per 2 books. See, each book is a half a carton. So that's 9 half cartons. 9 half cartons can be written like this. And you see, if I now just keep the adjective and ignore the noun, I have what? That 4.5 is 9 over 2. And the mechanical way of getting that, you see, is 2 times 4 is 8, plus 1 is 9 over 2. And another reason for getting that, you see, is that 4.5 means 4 plus 1/2. 4 means 4 over 1. 4 over 1 is the same as 8 over 2. So you see what's happening over here? See, 4 times 2 is 8, plus 1 is 9 over the common denominator, which is 2. So that's 9 halves. Let's practice that some more just to see if we get the hang of this thing. See, write 3 1/3 as a common fraction. Let's do it the mechanical way first, then see if we can understand it logically. 3 times 4 is 12, plus 1 is 13. 13 what? 13 thirds. Why is that? You see, if there were 3 books to a carton, 4 cartons would have 12 books, then you would have what? A 13th book, okay? And if there are 3 books to a carton, each book is 1/3 of a carton. So you see you have 12 and 1 of 13, 13 thirds. See, this is the mechanical thing you've done. You've multiplied the denominator times the whole number, added the numerator, and put the whole thing over the denominator. And the logic behind that is that 4 1/3 means 4 plus 1/3. 4 is the same as 4 over 1. Remember how we add fractions? We look for a common denominator. 1 times 3 is 3. 1 goes into 3 3 times. 3 times 4 is 12. You see where the 12 is coming from? 3 times 4 is 12. 3 goes into 3 once. 1 times 1 is 1. So there's 12 thirds and 1 more third. You see in the language of fractions what's happening here? 12 thirds plus 1/3 is what? 13 thirds. Add the numerator and keep the common denominator. Let's just practice some more. Let's practice some more. Let's suppose I said to you, write 187 over 7, 187 sevenths, as a mixed number. You see, right now, it's an improper or top-heavy fraction. Let's see what that means. We take the 187 over 7. I'm going to do this mechanically first and then show you the logic behind it. We swing the 187 down. See, 187 over 7 means 187 divided by 7. That means 7 goes into 187. 7 goes into 18 twice. 2 times 7 is 14. We subtract. We get a 4. Bring down the 7. 7 goes into 47 6 times. Gives me 42 with a remainder of 5. But that's what? 5 of the 7 that I need for another unit. So the answer here would be what? In chapter 3, it would be 26 with a remainder of 5. Now we write that as what? 26 and 5 of the 7 that you need for another unit. See why this is called a mixed number? You have a whole number plus a fraction that's less than 1. That's what a mixed number is. It's a whole number plus a fraction that's less than 1. And by the way, let's check this out. 7 times 26 is 182, plus 5 is 187, over the denominator, which is 7. There's our 187 sevenths. And if you want to see what this means in terms of a verbal situation, suppose you had 187 books, and you could put 7 books into a carton. Under these conditions, you see each book is 1/7 of a carton. So another name for 187 books would be 187 sevenths of a carton. And so all we're saying is that 7 books to a carton, if we had 187 books, we would have filled up what? 26 full cartons, and we would have 5 of the 7 that we needed to fill up the 27th carton. Do you get the idea on this? Let's do one more before I get to the main theme of today's lesson. See, right now, I just want you to become familiar with how you take an improper fraction and convert it into a mixed number, and conversely, how you can take a mixed number and convert it into a common fraction. Let's practice just one more time, and I'll get to the punchline. Example 5 says, write 8 and 4/9 as a common fraction. There are several ways you can do this. Let me just pick one way at random to start. First of all, 8 and 4/9. This is one case where the and means plus. That's 8 plus 4/9. 8 is 8 over 1. 1 and 9 have 9 as a common denominator. 1 goes into 9 9 times. 9 times 8 is 72. In other words, 72 over 9 is just another name for 8 over 1, which certainly checks out because 72 divided by 9 is 8. Remember, 72 over 9 means 72 divided by 9. So that's 72 ninths. 4/9 gives me 4 more ninths, so I have what? 72 and 4, which is 76. 76 what? 76 ninths. Notice I could have got the same answer mechanically by taking what? The denominator times the whole number. See, 9 times 8 is 72. That's the 72 over here. Plus 4, that's the same 4 I had over here. That gives me 76 over 9. And again, the way to look at this is the 9 tells me as a hint to think of 9 books per carton. If I have 9 books per carton, 8 cartons will give me 9 times 8, or 72 books, plus the 4 I have in the 9th carton gives me 76 books altogether. And if there are 9 books to a carton, each book is 1/9 of a carton. Now, the reason I bring this up is we will want to learn how to work with mixed numbers. In fact, the latter part of this lesson will be devoted to showing you one place where mixed numbers come up all the time. But I think you can already begin to see where mixed numbers are coming up. That when you divide one number by another, there usually is a remainder. And you see, the mixed number part helps us keep track of the remainder. For example, if I tell you that I have 7 full cartons, and in the 8th carton I have 3 books, have I told you how full the 8th carton is? No, because if the 8th carton only holds 4 books, I have 3 of the 4 books occupied. See, that's almost full. But if it held 50 books, I've got 3 of the 50. You see, the remainder just gives me the adjective. To get a feeling for the size, I have to have the adjective and the noun. So in many problems that we're going to deal with, we're going to deal with mixed numbers. What type of number do we already know about as to how to handle fractions? Common fractions. You see, in a sense, common fractions is going to be our natural language, and mixed numbers for today is going to be our second language, so to speak. Did you ever stop to think about how you learn a second language? Suppose you're studying French and you don't know it very well. Somebody comes up to you and they ask you a question in French. You don't answer that question right away. What do? You think about it and you translate it into English. And you digest that question. And once you understand that question in English, while you're still in your native tongue, you answer that question. Then, after the question is answered, then you translate that answer back into the foreign language. For those of you who have had a foreign language, have you noticed that's what you tend to do? You translate from the foreign language into your own language, answer the question in your own language because that's more comfortable, and then translate the answer back. In fact, my definition of being bilingual is simply the situation where when you hear the question in the foreign language, you answer it in the foreign language without even thinking about your own language. But at any rate, let me just summarize that for you here. Answering questions in the second language. Translate the question into your own language, formulate the answer in your own language, then translate this answer into the second language. Now, why do you think I'm telling you to do that? Because I'm going to show you now that one of the fringe benefits for having suffered through modules 4 and 5 with me, where we learned common fractions, is we can now solve any mixed number problem using common fractions. Let me give you a for instance. Problem number 6 says, write 4.5 times 8.5 as a mixed number. See, 4.5 is a mixed number, 8.5 is a mixed number. What we want to show is what? The product of two mixed numbers can be written as a mixed number. Okay, how do we write 4.5 as a common fraction? 2 times 4 is 8, plus 1 is 9, 9 over 2. So 4.5 is 9 halves. What's 2.5? 2 times 2 is 4, plus 1 is 5. 5 over 2 is 5 halves. And by the way, I've picked numbers that are easy for you to associate with money, for example. If you had $5 half dollars, wouldn't that be the same as $2.50? If you had $9 half dollars, isn't that the same as $4.50? So what have I done now? The foreign language is mixed numbers. My natural tongue is common fractions. That's why I want you to know common fractions. If you don't know your natural tongue, how are you going to learn an unnatural one? So make sure you understand the common fractions. So now 4.5 times 2.5 in the language of mixed numbers translates into 9 halves times 5 halves. This is a multiplication problem using common fractions. I know how to multiply common fractions. How do I multiply common fractions? I multiply the numerators. 9 times 5 is 45. I multiply the denominators. 2 times 2 is 4. So the answer as a common fraction is 45 over 4. Okay? Now that I have the answer as a common fraction, even though it's an improper fraction, what do? The drill I did before. I take the 45 over 4 and convert that into a mixed number. You see, the problem was given as a mixed number. I want to write the answer as a mixed number. You see, 45 fourths is a correct answer, but the instructions said write the answer as a mixed number. So I have to translate this into a mixed number. I swing the 45 down. 4 goes into 45 what? 11 times with a remainder of 1. And since the remainder indicates 1 part out of 4, I write the answer as 11 1/4. Okay, so let's summarize what I just said. You see, answering questions in a second language. 1, translate the question into our own natural language. 2, formulate the answer in our natural language. 3, translate this answer into the second language. Now you say, my golly, I didn't know this was going to be a semantics course. Why do I have to know this? And the answer is that if you have successfully struggled through modules 4 and 5, you have now acquired a natural language in terms of rational numbers, namely the language of common fractions. Today, we're going to look to see how mixed numbers work. And what we're going to do is, because mixed numbers will be our foreign tongue, we will translate any mixed number problem into a common fractions problem, answer the problem as a common fraction, then translate the answer into a mixed number. Let's take a look and see how this works. For example, suppose I say, write 4.5 times 2.5 as a mixed number. In other words, what's the product of 4.5 and 2.5? Well, remember, we already know how to multiply common fractions. And we also have learned how to convert mixed numbers into common fractions. So let's do that. 4.5 is what? 2 times 4 is 8, plus 1 is 9 over 2. That's 9 halves. Think of that in terms of money. $4.50 is the same as 9 half dollars. 2.5, 2 times 2 is 4, plus 1 is 5 over 2. 5 halves. $2.50 is 5 half dollars. Okay? Another, it doesn't have to be money. I mean, if I have 5 half pounds of candy, that's the same as 2.5 pounds. If I have 5 half gallons, that's the same as 2.5 whole gallons. Okay? Now what I do is, I've translated, see step 1, I've translated the problem from the foreign language into my natural tongue. 9 halves times 5 halves, well, how do you multiply two common fractions? You multiply the numerators, 9 times 5 is 45. You multiply the denominators, 2 times 2 is 4. So the answer in my language, common fractions, is 45 fourths. That's 45 divided by 4. So now we convert that back into a mixed number by saying 4 goes into 4 once. 4 from 4 is 0. Bring down the 5. 4 goes into 5 once. 4 times 1 is 4. 4 from 5 is 1. So the answer is 11 with a remainder of 1. And since the whole unit involves 4 parts, a remainder of 1 means what? 1/4. So basically the answer is what? 11 1/4. And so that we don't lose that answer, let's just refer back to the problem. What we're saying is that 4.5 times 2.5 is what? It's 11 1/4. And here again, we come to an old theme, the nice versus necessary, again and again and again. We're going to come to that all the time in this course. You see, the beginning student who has no feeling for the subject but just wants to shuffle numbers looks at something like this and says, hey, what could be more natural? I'll multiply the two whole numbers. That will give me 8. I'll multiply the two fractions. A half times a half is 1/4, so the answer is 8 1/4. Well, that may be natural, but it's wrong. Now, how do I know it's wrong? Well, look, since 2 1/2 is bigger than 2, whatever 4 1/2 times 2 1/2 is, it's got to be bigger than 4 1/2 times 2. But if I double 4 1/2, I get 9. See, 2 times 4 is 8, and 2 times a half is 1. And if this bothers you, do it in terms of money. $4.50 is $4.50, and if you double $4.50, you get $9. So the important point is, since 4 1/2 times 2 is 9, and 4 1/2 times 2 1/2 is bigger than 4 1/2 times 2, whatever the right answer is, the right answer has to be more than 9, and 8 1/4 doesn't fill the bill. In fact, let's check this thing out and do the problem in terms of a real-life example. Suppose you were buying 2.5 pounds of something for $4.50 a pound. 2 pounds would cost you $4.50 twice, that's $9. A half a pound would cost you half of $4.50. Half of $4.50 is 2 1/4. And by the way, have you noticed how much easier these problems are if you put a dollar sign in front? Most people are pretty good with math if they can see dollars and cents here. So it's $9 for 2 pounds, $2.25 for a half a pound. So at $2.50 a pound, how much did 4.5 pounds cost? It cost $11.25. And what's the colloquial way of saying $11.25? 11 1/4. 11 1/4. You see, let me show you what really happened here. In case you wanted to be bilingual, see, you might argue, hey, that was great that you got the problem by converting everything into common fractions, but I want to be bilingual. I want to solve this problem without using common fractions. Let's visualize what went wrong here. You see, when you say 4 1/2, that really stands for 4 plus a half. See, what's happening here is this is the sum of two numbers, and it's multiplying the sum of two more numbers. Remember when you have addition and multiplication in the same problem, even with whole numbers. Remember what happened when we multiplied two multi-digit numbers? Didn't each term in one number multiply each term in the other number? In other words, the correct way to do this problem, as I'll motivate for you in a minute, is that the 4 has to multiply the 2, the 4 has to multiply the half has to multiply 2, and the half has to multiply the half. And I'll show you that geometrically. Imagine that you had a rectangle that was 4 1/2 inches long and 2 1/2 inches wide. The area of a rectangle is the length times the width. If I draw in these blue lines here, do you notice that that breaks my rectangle up into 4 parts? One of these parts is 4 inches by 2 inches. That gives me 8 square inches. See, 4 times 2 is 8. How big is this piece? 2 times a half is 1. This is 1 square inch. A half times 4. You see, this is only a half. But look how long it runs. See, a half of 4 is 2, and a half times a half is 1/4. Now add up these little pieces. See, 8 and 2 are 10, and 1 is 11, and 1/4. You see, it's easier to multiply the whole numbers and to multiply the fractions, but you're missing part of the answer. When you just multiplied the 4 times the 2, and you multiplied the half by the half, what you were leaving out was this whole piece in here. It was almost right, but you know, you want the exact answer. You're throwing away quite a bit over here. But by the way, this comes up in algebra later on, and they teach you mechanical rules that people very quickly forget. In algebra, this is called the rule of FOIL. And who wants to learn that word? Basically, what it stands for is F stands for first, O stands for outer. I just want to show you how silly this is. I stands for inner, and L stands for last. And what this tells you is you multiply the two first numbers, you multiply the two outer numbers, you multiply the two inner numbers, and you multiply the two last numbers, and all it says is what? Make sure that each term in the first set of parentheses multiplies each term in the second set of parentheses. And if you think this is hard, don't worry about it. That's the beauty of not having to become bilingual. We will always take the harder problem and translate it into the language that we already know. Let me do a few more problems like that just to show you. Suppose I were to say to you, write 8 1/3 plus 2 1/4 as a mixed number. I do the same thing again. I'm going to translate from mixed numbers into common fractions. I'm going to solve the problem in the language of common fractions, then translate the answer back into a mixed number. So what's 8 1/3? 3 times 8 is 24, plus 1 is 25. 25 what? 25 thirds. 2 1/4, 4 times 2 is 8, plus 1 is 9. 9 what? 9 fourths. So 8 1/3 plus 2 1/4 is the same as 25 thirds plus 9 fourths. This is now a common fraction problem. I know how to solve common fraction problems. I put everything over a common denominator. 3 goes into 12 4 times. 4 times 25 is 100. 4 goes into 12 3 times. 3 times 9 is 27. So 25 thirds plus 9 fourths is 100 twelfths plus 27 twelfths. Since I have a common denominator, I keep the common denominator and I add the numerators, and that tells me that as a mixed number, the answer is 127 over 12. That means 127 divided by 12. Let's say as a mixed number, I meant as a common fraction. I want the answer as a mixed number, so I'm going to take what? 127 over 12 and convert that into a mixed number. How do I do that? I pivot down the 127. 12 goes into 12 once. 1 times 12 is 12. I subtract, there's no remainder. I bring down the 7. 12 doesn't go into 7. I bring up the 0. So the answer is what? 10 with a remainder of 7. That means 10 and 7 of the 12 that I need for the next one. The answer is 10 and 7 twelfths. In other words, when somebody says, write 8 1/3 plus 2 1/4 as a mixed number, the answer is simply what? Just write it down up here if you want. It's 10 and 7 twelfths. By the way, I would like you to see the structural difference between what happens when you add two mixed numbers and when you multiply them. This is why we've been stressing the associative and the commutative properties. Look, 8 1/3 means 8 plus 1/3. 2 1/4 means 2 plus 1/4. Now, rather than being connected by a times sign, they're connected by a plus sign. And when you're connected by a plus sign, isn't this an entire addition problem? And when you're adding, can't you regroup the terms any way you want? Since this is all addition, I can do what? I can add the 8 and the 2 to get 10, you see. 8 plus 2 is 10. And I can also do what? Group the 1/3 and the 1/4 together. You see, I'll rewrite this as 8 plus 2 plus 1/3 plus 1/4. What gives me the right to do that? Because addition is commutative and associative. At any rate, 1/3 is 4 twelfths, 1/4 is 3 twelfths, 4 twelfths plus 3 twelfths is 7 twelfths, so the answer is 10 plus 7 twelfths, which we write as 10 and 7 twelfths. And people find a shortcut way of doing this. Namely, what they say is, why don't we just change thirds and fourths to twelfths? So instead of saying 8 1/3 plus 2 1/4, they write the 8 1/3 as 8 and 4 twelfths. They write the 2 1/4 as 2 plus 3 twelfths. Then they say that 8 plus 2 is 10, and 4 twelfths plus 3 twelfths is 7 twelfths. That's fine, but notice that if you do the problem this way and you're not careful, that's conducive to making you say, why can't we just multiply the whole numbers and multiply the fractions? You see, make sure you understand what you're doing. My advice is that at the beginning, the long way is the short way. Do the problem the way you know how. And once you know how, you will discover shortcuts for yourself. That's the way I learned all my shortcuts. The only shortcuts I ever remembered are the ones that I learned for myself. I had a teacher who once told me, he said, when you've forgotten everything else you've ever learned, what's left is the only thing you can call education. You memorize those shortcuts, in a few months you're going to forget them. And once you forget them, you don't know anything. So make sure you understand what we're trying to do over here. Let's look at a few more problems. This one says, write 8 1/4 minus 2 1/3 as a mixed number. And again, I'm saying to you what? If you want to do this bilingually, fine. I just want to show you a technique that's going to work. Namely, we take 8 1/4, we translate that into 33 fourths. See, 4 times 8 is 32, plus 1 is 33, 33 fourths. 2 1/3. 3 times 2 is 6 and 1 is 7. That's 7 thirds. So 8 1/4 minus 2 1/3 is 33 fourths minus 7 thirds. 12 is again a common denominator. 4 goes into 12 3 times. 3 times 33 is 99. 3 goes into 12 4 times. 4 times 7 is 28. So I'm subtracting 99 twelfths from 28 twelfths. Well, since I have a common denomination, I keep the common denomination. 49 take away 28. 99 take away 28 is 71. So as a common fraction, the answer is 71 twelfths. Now I take the answer from my natural tongue, namely 71 twelfths, and I do what? I divide 12 into 71 and get what? 5 with a remainder of 11, so the answer is 5 and 11/12. Okay? Now, some people say, well, couldn't you do this problem directly? Couldn't you say that 8 1/4 is the same as 8 3/12? Sure, I could. Could I say that 2 1/3 is the same as 2 4/12? Sure, I can. Now, how would you subtract? You say, well, let's take 4/12 from 3/12. But I can't do that. And the reason that I can't do that is I can't take 4 away from 3. So what do? I borrow. And here's where you get into trouble mechanically. When I borrow, I had 8 units, so now I only have 7. What do I trade this in for? Please, don't put a 1 over here. Remember, I'm dealing with 12ths. And how many 12ths make up a whole unit? Not 10 of them, 12 of them. You see, what I do is I trade in 1 for 12 12ths, and that gives me altogether 15 12ths. See, add the numerator and the denominator if you're going to do it the direct way. Now, what? 4 12ths from 15 12ths is 11 12ths, which is exactly what we got here, and 2 from 7 is 5, so there's the right answer. The most common mistake that people make is they want to put a 1 over here, and you can't do that. Well, you can, you just get the wrong answer. If you exchange $1 for quarters, do you get 10 quarters or 4 quarters? See, it takes 4 quarters to make a whole unit. So the danger that you run is that if you try to become bilingual too fast, you will make careless mistakes. So take your time, make sure you understand things, and above all, once you get an answer, use common sense to check it. Let's do one more before we change to a new topic. Number 9 says, write 8 1/3 divided by 2 1/4 as a mixed number. And by the way, don't be afraid to estimate these things. 8 1/3 rounds off to 8 to the nearest whole number. 2 1/4 rounds off to 2. This rounds off to 8 divided by 2, which is 4. So before you even start this problem, you're looking for an answer that's approximately 4. Now, how do we do this problem? 8 1/3 is 25 thirds. 2 1/4 is 9 fourths. So we have 25 thirds divided by 9 fourths. How do we divide two fractions? We invert the second one and multiply. See, that's our natural language. It's 25 thirds times 4 ninths. That gives me 100 over 27. Now to convert that, I divide the 27 into 100. That gives me 3 with a remainder of 19. That's 3 and 19 27ths. By the way, is that a plausible answer? We were expecting about 4 for the answer. This looks pretty close. And by the way, check it out. This says that the correct answer is bigger than 3, but less than 4. Let's check it out. What are we looking for? We're looking for the number such that when you multiply it by 2 1/4, you get 8 1/3. 2 1/4 times 3, 2 times 3 is 6. 1/4 times 3 is 3/4. That's 6 3/4. 2 1/4 times 4, 2 times 4 is 8, and 1/4 4 times is 9. So 3 would give me 6 3/4. 4 would give me 9, and the answer I'm looking for is 8 1/3. So I'm certainly in the right range. I'm between 3 and 4. Now, let me show you a very special place where mixed numbers come up quite frequently. It's a very special kind of rate. The special rate is called percent. Cent is from the Latin centum, which means 100. Per 100 means divided by 100. In fact, you know, that's where the percent sign came from. When you type a fraction, you usually use a slash mark instead of a horizontal bar. So to abbreviate divided by 100, people usually wrote this. Then what they did was, to get around using both ones, they just used the slash mark and put it between the 2 zeros, and that's where the percent sign came from. But when you hear the word percent, just think of what? Per 100. 7% means 7 parts per 100. So let's take a look at how this comes up. Did you ever take a test in school, and let's say there were 13 problems on the test, and you get 10 right, and the teacher gives you back a grade like this, 10 over 13. So you got 10/13 of the exam right. You said, oh my gosh, I don't know if that's a good grade or a bad grade. How often are you tempted to measure your grades in terms of a scale of 100? And we'll talk more about that in our next module, but aren't you used to grading in terms of 100? See, the question that comes up is, at a rate of 10 out of every 13, how many would I get out of every 100? Well, look, if I multiply 13 times 7, and 10 by 7. That would give me 70 over 91. So at a rate of 10 out of 13, that would be 70 out of 91. If I multiply numerator and denominator by 8 here, I would find that the rate of 10 out of 13 is the same as 80 out of every 104. So a rough estimate would be what? That at a rate of 10 out of 13, I'm getting more than 70 out of 100, but less than 80. But the question is, what's the exact mark? Well, you see, if the whole grade is called 100%, see 100 parts per 100, I'm asking how much is 10/13 of 100%. Now, do you see what happens over here? Of means times. How do you multiply? 100 is the same as 100 over 1. When you multiply two fractions, you multiply numerators, you multiply denominators. 10 times 100 is 1,000. 13 times 1 is 13. That's now an improper fraction. I divide 13 into 1,000. 13 goes into 100 7 times with a remainder of 9. 13 goes into 90 6 times with a remainder of 12. So the answer is 76 and 12/13. In other words, going back to this, if you got 10 right out of 13, based on a scale of 100, you would have had 76 and 12/13%, which probably on the test would have been rounded off to a 77 or maybe an 80. But do you notice what happens over here? We're much more comfortable dealing with a scale of 100. And let's just practice one more time with that. See, suppose I were to say to you, write 7/11 exactly as a percent. What that means is, at a rate of 7 out of every 11, what's the exact number you would take out of 100? And the way we word that is what? To take 7/11 of 100. See, at a rate of 7 out of every 11, out of 100, we take 7/11 of 100. That's 7/11 times 100. 7 times 100 is 700. 11 times 1 is 11. We divide the 11 into 700. We get what? 66. That's 4. Bring down the 0. 11 goes into 43 times. That's 33. Difference is 7. 7 out of what? 11. So, in other words, at a rate of 7 out of 11, how many are you taking out of each 100? You're taking 63 and 7/11. And written exactly, you see the answer would be 63 and 7/11%. And to get a quick estimate of this, notice that 11 goes into 99 9 times. 9 times 7 is 63. 11 goes into 110 10 times. 10 times 7 is 70. So you're taking 63 out of every 99. You're taking 70 out of 110. So it seems plausible that you're taking what? Just a smidgen over 63 out of every 100. Do you get the feeling of how this is done? By the way, sometimes there are certain fractions that are very easy to write as a percent. Not very often, but sometimes. For example, notice that 1/4, because 4 goes into 125 times, 1/4 is the same as 25 hundredths. 25 hundredths means 25 per 100. That's 25%. See, just as a check, 1/4 of 100%. 100 divided by 4 is 25, times 1 is still 25. So suppose somebody said to me, how much is 24% of 800? Before I even start this problem, I say, hey, 24% is just a smidgen less than 25%. 25% is 1/4. 1/4 of 800 is 800 divided by 4, which is 200. So therefore, the answer to this problem is going to be just a little bit less than 200. That's the way I want you to learn to be able to think. Practice until you develop a number sense this way. But suppose it's hard for you. Just do the problem mechanically. See, what the problem says, by the way, is at a rate of 24 per 100, see, 24%, at a rate of 24 at the rate of 24 per 100, how many are you going to take out of 800? And in fact, you can almost do this in your head, I bet. How many hundreds are there in 800? 800 is the 8th multiple of 100. So if you're taking 24 out of every 100, out of 800, you're going to take 24 8 times, and 24 times 8, as we'll check in a moment, is 192. But again, suppose you don't have that number sense. You say, okay, 24% means 24 divided by 100. See, percent is per 100. Per means divided by. Of means times. 24 divided by 100, in the language of common fractions, is 24 over 100. 24 over 100 times 800, We cancel the 2 zeros in the numerator with the 2 zeros in the denominator. What are we left with? 24 times 8 is 192. 1 times 1 is 1. The answer is 192 over 1, which is 192 divided by 1, which is 192. And by the way, there are other ways of doing this. I don't care how you do it. For example, at a rate of 1 part per 100, out of 800, see 800, remember 1% means 1/100th. 800 divided by 100 is 8. See, in other words, just chop off the 2 zeros. 1% of 800 is 8. 24% is 1% 24 times. In other words, you're taking 8 24 times. The answer is still 192. Sometimes we get into a real mess because somebody gives us 2 nasty symbols. Look, in this lecture, we're learning mixed numbers allegedly for the first time. Allegedly simply means it's the first time I'm bringing them up in this course. See, today is the first day in the rest of your life. Whatever happened before this course doesn't count. Only from the beginning of this course can you blame me for your math troubles, okay? So what have we learned today? Mixed numbers and percents. Now all of a sudden, I have both of these in the same problem. Somebody says to me, write 2 1/3% as a common fraction in lowest terms. Doesn't that look a little bit scary? 2 1/3%? Well, translate what that means. 2 1/3 percent means what? Per 100. So if you have 2 1/3 per 100, see, what happens if you, see the denominator here is 3. If you take 2 1/3 3 times, what do you get? 2 times 3 is 6. 1/3 times 3 is 1. 2 1/3 3 times is 7. And by the way, if you don't believe that, just add it up. 2, 4, 6, 6 1/3, 6 2/3, 6 3/3. That's 7. 7 parts per what? 300. Listen to the psychology of this. If I say to you, take 2 1/3%, you say, oh my gosh, what's he talking about? But if I say to you, out of every 300, take 7, do you hear any fractions there? Do you hear any mixed numbers? Do you hear any percents? 7 out of 300 sounds simple to understand. And that's all 2 1/3% means. It means take 7 out of every 300. And another way to see that is, look, 2 1/3% means 2 1/3 divided by 100. 2 1/3, 3 times 2 is 6 plus 1 is 7, is 7/3. Divided by 100, 100 is 100 over 1. Whenever you're going to invert something, always write it over 1 so you can see what's going to happen. This becomes what? Leave the 7/3 alone, change the division to a times, flip this one. And how do I know that? Because I'm supposed to know how to divide rational numbers in common fraction form. This is 7/3 times 1 over 100. 7 times 1 is 7. 3 times 100 is 300. There's the same 3 parts per 300. And by the way, if you want to do this the fast way, notice that without the percent sign, 2 1/3 would be 7/3, wouldn't it? And percent means to divide by 100, and to divide a common fraction by 100, you just throw 2 zeros into the denominator. So I don't care which way you do it. What I want you to see is what? If you're frightened by the notation 2 1/3%, change it to what? 7 parts per 300, which is much less threatening. And from that, we can go on to bigger and better things. And again, notice that a percent is a rate. You see, 2 1/3% doesn't sound like a very big portion, but 2 1/3% of what? See, let me give you an example. Problem number 13 says, how much is 2 1/3% of 9,000? What we already found out is that 2 1/3% is 7 out of 300. So instead of 2 1/3%, we replace that by 7 300ths. Is this a hard problem? No. In fact, I'll even do it the long way here. I won't even reduce here. All I'm saying is what? 7 times 9,000 is 63,000. 300 times 1 is 300. We reduce this to lowest terms. The 3 goes into 630 210 times. You could have done it this way. You could have crossed out 2 zeros here with 2 zeros here. Then you could have said 3 goes into 90 30 times. 30 times 7 is 210. So in other words, at a rate of 2 1/3%, at a rate of 2 1/3 out of each 100, you'd be taking 210 out of every 9,000. And a quick way to check this is 1% of 9,000 is 90. See, cross off 2 zeros, 1 part per 100. 2% would be double 90, that would be 180. 3% would be triple 90, would be 270. So therefore, 2 1/3% has to be between 180 and 270. And notice how that keeps you from making real serious careless mistakes. Now, the other thing you still have to remember is you're not out of the woods just because you've learned a new vocabulary. Every time you've learned new vocabulary, everything that you've learned in the past still is applicable. Watch how quickly multiplication problems turn to division problems, even though I'm using percents and mixed numbers. A salesman earns 2 1/3% of any sale as a commission. If his commission is $140, how much was the sale? Well, see, what does this problem tell us? It says if you take 2 1/3% of the sale, that will equal the commission. The tricky part in this problem is the reading comprehension. The $140 wasn't the amount of the sale. The $140 was the amount of the commission. How do you know that? Because that's what it says. You have to be able to read whether you like to read or not. You see, the problem says if his commission is $140, how much was the sale? If the commission was $140. So I have to replace the commission by 140. The sale price is what I don't know. 2 1/3% is still 7 over 300. This is 7 over 300 times blank equals 140. See, this looks like a multiplication problem, but it's really what? A division problem. And which way does the division go? It's the 140 divided by 7 over 300. And if this bothers you, put in easier numbers. See, write down 2 times blank equals 6. What's the answer to this problem? It's 3, isn't it? How'd you get the answer? You took the 6 and you divided it by 2. You took the number on the right-hand side of the equal sign and divided it by the number on the left hand. So the same structure is going to work over here. You take the number on the right-hand side, which is 140, divide that by the number on the left-hand side, which is 7 over 300. But how do you divide 140 by 7 over 300? You invert and multiply. See, and now how does this go? 7 goes into 140 20 times. 20 times 30, well, times 300. 2 times 3 is 6. 3 zeros is 6,000. So in other words, to make $140, he has to sell $6,000 worth of material. And that's very exciting, because 2 1/3% doesn't sound like much, but on $6,000, he makes $140. That's called a big ticket item. He doesn't get much of a percentage, but he gets lots of hundreds of dollars in the sale, so he's making $2 1/3 lots of times. And by the way, if this still bothers you, don't be afraid to use your common sense. Don't be afraid to use whole numbers. Look, at a rate of $7 per 300, multiply both numbers in this rate by 10. That's $70 per $3,000. Since 3,000 is half of 6,000, double both of these, and what do you get now? 70 times 2 is 140. 3,000 times 2 is 6,000. At a rate of $7 per 300, you're going to make $140 per 6,000 without doing anything else, except making the sale. Okay? And let's just do some more here. Let's take a real small percent. How do you like this one? 1/2%. Not 1/2, but 1/2 of 1%. See, 1/2 of a percent. See, write 1/2% as a common fraction in lowest terms. You see, 1/2% means 1/2 per 100. Multiply this number by 2, multiply this number by 2. If you take 1/2 out of each 100, that's 1 whole unit out of each 200. So 1/2 of percent is 1 part per 200. And another way of seeing that is, you see, 1/2%, that's 1/2 per is divided by 100. 1/2 divided by 100 is the same as 1/2 times 1 over 100. That's 1 times 1, which is 1. 2 times 100 is 200. So 1/2 of 1% is half of 1%. 1% would have been 1 part in 100. So 1/2 of 1% is what? 1 part in 200. That's all it's saying. You're going to get $1 out of every 200. And you see the short way of doing this? All you do is what? To drop the percent sign with a common fraction, just throw 2 zeros into the denominator. You say, boy, what a big spender. He's going to give me $1 out of 200. Boy, is he a spender. But if it's a big ticket item, be careful. What's 1/2 of 1% of $500,000? We just saw that 1/2 a percent is 1 part in 200. Of means times, so the 200 goes into the 500,000. Cross off 2 zeros, that leaves you with 5,000. 2 goes into 5,000 2,500 times. 1/2 of 1%. If the sale is $500,000, your commission is $2,500. If you have an in for selling these items, and you can sell 6 of these a day, that's great. You're going to make $15,000 a day. Boy, I'd give $1,000 to be a millionaire. God. Anyway, enough of that. By the way, let me again show you a quick estimate. What would 1% of $500,000 be? Cross off 2 zeros. 1% would be $5,000. So a half of 1% would be $2,500. See, don't confuse 1/2 of $500,000 with 1/2 of a percent. 1/2 is 50%, right? A half of the whole amount. A half of 100% is 50%. Anyway, I think I've talked too long today, but why should today be different from any other day? I want to show you the beauty of a second language. I want to show you how, if you're willing to think, and you're willing to learn common fractions, and what it means to take so many parts per so many parts, mixed numbers and percents are yours as a bonus. No 800 number to dial, you just pick them up and go home with them. And I want you to read this module, I want you to study it over, I want to make sure that you can do every problem in the self-test, and if you have any trouble, come back and see me when you get to self-test 6, Form B. Until then, continue to have fun, stay young, learn hard.